All right, let's take a look here at number 13, and we're told to express f of x in the form f of x equals quantity x minus k times q of x plus r for the given value of k, and we're given the function f of x equals 2x to the fourth minus x cubed minus 15x squared plus 3x, and we're told that k equals -3. All right, so there looks to be a lot going on here, and there is, but nothing we can't handle. So let's take this step by step, and what we'll do is we'll come back to this part of the directions here. This f of x equals quantity x minus k times q of x plus r. This is really a special case of the division algorithm that we'll talk about at the very end. But with something like number 13, simply recognize that our primary goal is to perform synthetic division here. And we're going to perform synthetic division with the given k value. So in this case, we've been given k equals -3, and so we will use -3 with our synthetic division. All right, if you watch some of our previous videos talking about synthetic division, you'll know that what we want to do before we actually start is take a look here at the given function and make sure that we have powers that are in descending order and that we're not missing any powers. So it looks to me that the highest degree that we see is 4, and from 4 we go to 3, and from 3 we go to 2, and from 2 we go to 1, and from 1 we don't have anything. So we are actually missing a power. We're missing the x to the 0 power, or what would otherwise be considered a constant term in the previous videos that we've worked on. And we really do need that constant term to be filled in before we start our synthetic division. So just like before, let's go ahead and rewrite our given function here, and we're going to fill in the missing term. In this case, we're going to fill in the x to the 0, or again, otherwise what would be known as the constant. So here we have 2x to the fourth, which was already there, minus x to the third, minus 15x squared plus 3x, and again we are missing that constant term, so we'll go ahead and fill it in with a plus 0. And if you want to, you can think of this constant term as being 0x to the 0, and now you can definitively see how in fact we are in descending order. We go from 4 to 3 to 2 to 1 to 0. All right, because remember, anything to the 0 power is just 1. So adding x to the 0 doesn't change the value of anything because it's simply like multiplying by 1. So now that we have all of our terms filled in, we can go ahead and take the coefficients of each term and move them down here and then perform our synthetic division. So we see our x to the fourth, the coefficient is +2. The coefficient of our x cubed term is -1, and take notice that we're bringing the sign with the coefficient, right? Here in our x squared term, the coefficient was -15, so we'll bring that along. Here, our x term, the coefficient is +3, so that comes along. And here, the constant term, or the x to the 0 term, the coefficient is 0. All right, now that we've got all of our coefficients, let's go ahead and start the synthetic division. We know that with synthetic division, no matter what this first number is, we always bring it down, and so we'll bring that 2 down. And now we'll go ahead and multiply. -3 times +2 is -6. Then we add vertically, so -1 plus -6, -7. -3 times -7 is +21. Let's add vertically, so -15 plus 21 is +6. -3 times +6 is -18. Again, let's go ahead and add vertically. 3 plus -18 is -15. And finally, -3 times -15 is +45. And 0 plus 45 is +45. And we know that whatever the last number here is will be our remainder. So I like to kind of section that off. All right, so to the left here, what we have is our answer, except we are missing our x terms, so we have to fill them in. And you'll recall that when we're going to fill in our x terms, and let me go ahead and get rid of some of this here, we go back to the original function that we started with, and we want to look to see what the highest degree was. In this case, the highest degree was a 4. We're going to subtract 1 from the highest degree, which gives us a 3. And so this is what the degree of our first x term is going to be in our answer. All right, so again, go to the highest term, subtract 1, and that will be the exponent of the x that you start with. So in this case, x to the third. And from x to the third, we go to x to the second. This here was a positive 6, so we'll say plus 6 x to the first. And then from x to the first, we go to our constant. And so we have 2x cubed minus 7x squared plus 6x minus 15. All right, now this is where we're going to come back and start piecing these things together here. So what we just found here on the left, we are going to define as being q of x. And sometimes you may hear people refer to this q as quotient, and that kind of reminds you what it is that we're going to label what we just found as. So this 2x cubed minus 7x squared plus 6x minus 15 will go ahead and let be q of x, and this q of x here that we just labeled is going to be the q of x that we're looking for up here in the directions. The r in the directions, this plus r, refers to the remainder. All right, so this here is the r that we need. So we have both of these pieces. We have the r, we have our q of x, and now last thing we need is to find what this x minus k is. And this x minus k, notice the k term here, well, that's closely related to this k minus, k equals negative 3. So to find what x minus k is, all we're going to do is take that expression, x minus k, and we're going to plug in whatever they told us k was, right? So in this case, we'll say x minus, and we were told that k is negative 3, so we'll plug in negative 3. And then we can go ahead and simplify. We'll distribute that negative sign through, so we end up with x plus 3. And so now this x plus 3 is the term that we're looking for, this x minus k. And now that we have everything, we have our x minus k, we have our q of x, we have the r, we're going to plug all of this together and give them our final answer. So what we're looking for is f of x equals, what is x minus k? Well, we just found x minus k to be x plus 3. What is q of x, our quotient? Well, that was 2x cubed minus 7x squared plus 6x minus 15. And I'm running out of room, so I'm going to move this over just a little bit. And then plus r, well, what is r? Well, r was positive 5, so we'll say, or rather 45, so we'll say plus 45, and there is our final answer. All right, so again, I know it looks like a lot, but just realize the primary task that you're performing here with number 13 is synthetic division. Once you've performed your synthetic division, you have your remainder, if there is one, you have your q of x, your quotient, and you have your x minus k. You've just got to plug in the k value into this x minus k expression and simplify. And once you've done that, put all three pieces together, and there's your final answer.